Started the recording. Okay, so just a quick recap. Till yesterday, we have covered Python. So basically, the end chapter on Python was Python as a data engineer tool. There we have learned how to connect Python with an external database server, and we can pull the data from database as well as we can push the data inside the database. Okay, so that particular thing we have worked. And we also worked on top of data frame manipulation and all. So as of now, for the crash course perspective, as a data engineer, we have covered for the Python we have done. But if there is any doubt, any understanding issue, you can ping me. You can ping me over here, or we can directly discuss over here as well. But please feel free to ask if there is any doubt or anything, any stuck point or any such thing. Can ask. From today onwards, we'll be starting some new topic that is called business intelligence. This is the basic topics. In the data side, how we are working. What is our main motto? What is the goal to achieve the, uh, particular data from the business side? What business is trying to achieve from the data engineer's perspective? Okay, why data engineering is so much important? This is one more step. We are doing some business intelligence analysis. Is for business. Business is trying to increasing their revenue daily basis or quarterly basis, monthly basis. So they are trying to check the hidden trend of their business insight by looking into their data, their daily basis transactions. Okay, so this kind of stuffs, and they're trying to check the hidden trend, what is causing, what is lagging. So they're checking this thing from their data hidden pattern. So that hidden pattern is not easily can be solvable if there is lakhs of transaction for a store owner. Okay, so particular shopping mall, there is maybe more than thousands transactions per day. A bank or maybe an insurance company is having more than lakhs transaction or million transaction per day. So to check their, business insight, they need the data engineers. Okay, so data engineers can help us. Can help the business user or business admin or business owner to make various chart graphs, meaningful data, I can say. And from the transactional data, they can create as a meaningful data over there. By looking the same thing, the decision owner or the business owner can take the easy decision so that their business is having a correct growth. So this is the importance of BI, and whatever we have learned till now, SQL, Python, those are the component to develop the entire BI scenario. Okay, so this is the ultimate goal. So from today and tomorrow, there should be BI classes. So this is not much technical. Maybe when we'll be learning how to create the fact and dimension table, inside the data mart, the logic is same. The create statement, DDL, those are same. But while creating the same thing, we need to keep in our mind which particular column should be reside in a particular table. So those kind of technical knowledge we will be covering tomorrow. While learning fact and dimension data. Okay, so this is inside the data mart I'm telling about. But the thing is overall, it's not much practical. You just need to understand what is our ultimate goal, and from a high business perspective, or maybe from high architectural perspective, what should we do to develop the business intelligence? Okay, so let me start off the PowerPoint. Okay, so I just cropped some pictorial representation over here so that you can easily understand. So BI application. So I just took an example. It's a particular shopping mall. We are taking daily basis transactions. Okay, so but the particular shopping mall has different outlets in a particular country. So this is the BI application which is collecting all this information. It's not only sales data as well. It may be we can also maintain some data for the employees as well. Who are the employees working for this particular organization over there? Maybe what is their remuneration and how how good they are, how good each of them are to convincing for a particular product to the user. So those kind of stuffs, we can put them rank, we can give them some special allowance for the particular customers, I mean, for a particular employee. So this kind of stuff, every data we can store in the BI application related to this particular organization. Okay. So BI application is storing everything, and the BI application is processing data. Data engineers are processing data. They are making this data is meaningful one and storing it to database. Okay. And even they can design some more visualization thing, just like in Tableau, in Click, they're creating those kind of meaningful data into graphs and charts. And those graphs and charts are helpful to check what is the sales in previous quarter. Okay. So what is, they can also compare, there is a line chart that they can compare what is the comparison between previous quarter and this quarter. Okay. So revenue growth in last 5 years. What is the best selling product in that particular season? Maybe what is the worst selling product, that may be also helping me. So suppose I'm just giving you an example. For a particular store is having multiple outlets. For a particular outlets, a product is not being sold. Just only one or two product has been sold by one or two customers. Okay. But the manufacturing unit is continuously producing that product, and it's delivering the same product to this outlet. But by analyzing that thing, someone checked that that particular product is very rarely bought by the users. So that's why they can take the decision that we cannot distribute this product into that particular outlet, but the other outlets are fine. So these kind of decision they need to take. And if they started, I mean, decreasing for that particular product's production from the production unit, then the money should be saved. They should be having less loss. Okay. So this kind of business decision can be easily taken if the BI applications are good. If the data engineers are making it correctly, meaningful data by the SQL query or Python or whatever tools are there. Okay. So this is the ultimate goal. If we are joining in any company, we need to know what is BI and who is the architect. They need to know everything. And they can give you, if you are new joining, they can give you small component work, maybe SQL, maybe Python, maybe there is another tool, ETL tool, which is doing the same kind of operation. But the overall thing, what the business owner want to check, this is the thing. Okay. Okay. So I just give a brief, I mean, this is a cycle that is called BI cycle, business intelligence cycle. So OLTP system is the source system where the data is getting, where the data resides in the source. Okay. We can say OLTP system. So by ETL is a tool. I'll be coming later. What is ETL? ETL, maybe Python can be working as a ETL as well. So that particular tool will be loading the source data in a meaningful data in data warehouse. Okay. So this can be a database, we can say, just like MySQL server, your Snowflake server, or any Teradata server, Oracle, any particular database, they can store the source systems data into meaningful one with the meaningful tables as well. In the source, we can get lots of records or lots of columns, which is not required for business analysis. So we just need to do the extract, transform, load over here. Which column or which thing is not required, we can remove that, and we can store the meaningful one into data warehouse. Then in the reporting layer, the visualization team can create charts, graphs, meaningful charts as well. Variety of, pie charts as well, anything, histogram. So any kind of what is required for, usual scenario, that kind of thing should be taken care by the reporting team. They can create those graphs and charts. And then decision owner or the planning strategy maker, they can take the decision what should be our next target. So they can change the production unit, or they can take the good decision to upgrade their growth. So business process improvement, they are updating the thing. by this way into source system again. Now, if you can check the next day's graph and chart, we can easily see there is more revenue than yesterday or less loss than yesterday. So this kind of stuff, this is a BI cycle, and we are working in this portion only. Okay. If I am a company owner, or I have done, some business strategical thing, then I can work with the company itself in this process. I mean, over there. Even I need to know the IT knowledge as well. The decision strategy planning or owner, they are also having the IT knowledge. They are also having those data engineering knowledge as well. But as per our motto over here, we are working in this part. Okay. We are taking data from the source system, working in ETL, pushing it to DW, and we can also going ahead with reporting tool by creating charts and graphs and providing everything to the business owner. Okay. Okay. Going to the next slide. Hopefully that is understandable. Now I'm coming to what is OLTP. So this is called OLTP actually. What is OLTP? Okay. Today's session is mostly theoretical, and also that can be, if you are going to have a new interview on the data side or anything, they can definitely ask this kind of questions as well. Those are very much theoretical, but those can be asked in your interview. Or already we have already faced an interview. You have joined the company. Then that kind of thing can be, required when you are just working with directly your business owner, business manager. They can use this kind of terminology: OLTP, OLAP, OLAP. So this kind of stuffs, or other things are there as well in the next slides. So just try to have some knowledge on that one. If you are stuck in any point, you can quickly ask me. Okay. So OLTP means this is mainly the transactional data. It's called online transaction processing. So whatever daily basis transaction is there in the store or any other thing, maybe in bank, maybe in insurance company, maybe in any pharmaceutical company. So whatever transaction is going on daily to daily basis, that can be stored in OLTP system, OLTP databases. Maybe SAP or .NET framework is been handling that kind of thing. We are putting the data in the user interface, and those are directly going to be stored in a particular database. So that is called OLTP, transactional data. This one. Okay. Going to the next slide, OLAP. OLAP, it's also called OLAP. So, in data warehouse, what we are storing? We are storing the data in OLAP format. So in ETL and the intermediate process, we are just going through this thing. We are processing the OLTP and creating more meaningful data, which can be good for analytical purpose. Okay, suppose we can just go ahead with some group by or any other aggregation on top of the OLTP data, so that those are we can call this is for analytical purpose. We can store the thing in OLAP, that is the data warehouse. Okay, the DW side in the previous example. So that is called OLAP, online analytical processing system. Okay, so after pushing the data in OLAP, then it's work for decision support system. They need to check this kind of metrics. What is the sales distribution region wise? Per region, what is the sales? How much profit does a particular product contribute? So this kind of questions, it can be helpful from this meaningful graph to the decision support system. Okay, they need to check lots of stuff. Mainly, they have done their MBAs. Okay, generally, those are the guys. Check this kind of thing. They completed their MBA. They can take the business strategy in the next level, or those kind of stuff. Who are my profitable customers? Then I can give some extra effort to the customer, extra features or extra benefits, some free of cost products, maybe some cashbacks, awards to them. Okay, this kind of stuff. Okay, so just I tried to convey the thing. This kind of OLTP data we are getting. Okay, and we are converting into meaningful way in the dashboard side. This is the ultimate goal. Then we can zoom in, zoom out this kind of chart and graphs. So then business decision owner, they can take the easy decision on top of this one. They cannot take the decision from the raw data, but they can take easy decision from this kind of charts and graphs. So we are preparing this kind of data on top of source data. So that is the work for data engineer. Okay. So maybe we are not doing the entire steps. Maybe someone is working in the data part, some other team is working in the visualization part, but we are doing some component to convert to this particular chart. Okay. If our main motto is working in data. Okay. Till now, any doubt from anyone? I can see lots of new people has been joining. So if there is any doubt for today, kindly ask me. Okay, hopefully everything is fine. Going to the next topic. Yeah, just mention a quick points. If the world do not have the DSS, decision support system, so we are transactioning the daily basis, but there is no value of this kind of data storing. So we are storing the data, but the data is nothing to do. We cannot do anything. Data can be spread across the organization. We cannot consolidate the data, and we cannot take the decision. Okay. So if we do not take the decision, if there is any hidden pattern of, I mean, uh, growth, hidden pattern of decreasing growth of your organization, we cannot easily detect those kind of stuffs. There is very low productivity in our company as well as our IT department. Okay. We can do the repetitive work as well. Whatever we have covered that cannot be tracked in the databases. So just like whatever data we are producing during the transaction, there is no such use on top of that. So that's why DSS is very much important. Okay, now what is data warehouse? That is the OLAP. Just I have represented in a pictorial diagram. So those are the data entry operator who are pushing daily basis transaction. This is called operational database. And this is the ETL tool where we are extracting the data and pushing it to data warehouse. And finally, the report is presented to manager or the DSS, anyone. So I'm starting with the data warehouse part, what is called data warehousing and how, I mean, what kind of data is being stored in data warehouse and this kind of stuffs. Okay. So data warehouse, especially it should be some subject oriented, obviously. Maybe we are storing some insurance data for a particular insurance company. Suppose AIG. Suppose I'm taking data from a pharmaceutical company. It is called J&J. Okay, Johnson and Johnson. So this kind of stuffs, I mean, J&J is having pharmaceutical product as well as some other product as well. I mean, not only pharmaceutical product, they're having medical devices. So for each of the topic, we can create separate data warehouse. We cannot merge medical devices or maybe vision care related stuffs, contact lens and everything. And even its pharmaceutical product, the medicines and all in a single data warehouse. So it should be subject oriented. Okay, so which subject we are playing the role, maybe that can be splitted. Maybe it's totally dependent on the business owner as well, how he or she wants to segregate the particular subject and pushing it to data warehouse. So data warehouse should be subject oriented, integrated, okay, time variant. So in previous, I mean, whatever we have stored, the historical data we can check. I mean, maybe someone wants to check the hidden pattern or maybe the growth pattern from last 10 years or 20 years. So that's why the old historical data can also be saved. So that is why it's time variant and we can easily track the record quickly from the data warehouse. Non-volatile. So it can be always accessible from any point of time because on top of the data warehouse, data scientist team can work, the data analytics team can work on top of that one. Even the visualization team or reporting team can work on top of the data warehouse. They can build charts and graphs. If suddenly the data warehouse got erased, all the data got erased, then the charts, I mean, on top of that, the chart, graphs, those are showing blank record. There should not be anything, any line chart, any pie chart, any bar diagram. bar chart, there should not be nothing to display if the data warehouse got blank. So that should be non-volatile in nature. So data should be always present over there. So we need to choose the database in this way. Okay. So now onwards, I mean, daily basis, it's also getting, I mean, very much scalable, as well as we can see everything is moved into cloud. So in cloud, there is lots of, I mean, damage control things. If anywhere any server was down, then there is another server for the backup side, or we can have the snapshot for each days. So there is a mechanism to, if suppose we have dropped a table, or if there is something occurred with the database, then there is another option to recreate the same database again from the previous old history. So just like we have the timestamp or the time travel capacity or the new databases as well. If you're quite aware for the Snowflake database, so it's totally dependent on the cloud, and we have lots of cloud features and functionality to have that kind of, I mean, user friendly behavior. Or if there is any wrong, we can quickly go through the time travel and bring it back again. Those kind of stuffs. Okay. So maybe while doing the SQL query, we should be having less lag. So this kind of stuff should be the parameter of which kind of database we'll be choosing to store or to be worked as a data warehouse part. Okay, so those kind of stuffs I already mentioned in a low pictorial level. This is a high pictorial level. I just want to mention the same thing. So we are how we are storing the data. In a suppose we are I'm the owner of a particular banking industry. Okay, so for the banking industry, there is not a single way to have the data. For separate bank, maybe, or maybe for separate outlets of the bank, we may be having different source system. So those are different source system. Okay, those are external source system. We are collecting information daily basis from there, and there this is the first step where we are keeping those records in a staging area. Okay, this is called staging layer. So daily basis data is coming, and staging data should be truncate and load method. We can loading the data over here. Just, I mean, there is no such transformation over here. We are just directly mapped it one to one, but different source systems data should be pushed over here. So we are in the single stage area. We are having every data without transforming anything. Now in this area, we are cleaning the data, transforming the data, whatever is required as per our business. We can transform the same thing, and maybe some aggregation summarization we have to do, maybe some short function we need to apply, maybe we need to convert the data in proper manner. So this kind of stuffs we have to do, and we have to store the thing in data warehouse, and if required later we can move it to data marts. Okay, so this is the entire thing for the a data team or data engineer to do the entire thing over here. There is a metadata layer. So in ETL, this process, cleansing process, aggregation function, we need to store some metadata information. Just like we are loading the data based on particular timestamp. Suppose daily basis, we need to refresh the data. So previous day, whatever transaction we made, we can load the data from here to here. But we just, I mean, track the thing in metadata, what particular till what timestamp we have loaded the data. So from when the next day's job will run, it will check in metadata which last particular date they have covered the data load. So greater than that timestamp, they will be loading next day's data. Okay, so this is the original process for metadata. I mean, how metadata is useful? Just I tried to convey in this way. Metadata is keeping the admin related operation, which timestamp we have loaded the previous day's data, maybe some flag, or I mean, it's totally admin related data for this kind of data storage. It's not business related data. It's not storing the business data. It's having the admin related data for each of the storage level. Okay. So suppose we are checking for a particular day's transaction, how many transaction has been occurred. Okay. So today the source system has captured 20 millions of records. So that kind of information can be stored in metadata layer as well. But that information is not useful at the business side. How many records we have stored today? Business doesn't have this kind of knowledge. They do not bother to take this knowledge. So that is our purpose, our job. Okay, maybe user can say, I missed that record today. A particular customer called Sam. So he purchased that product, but there is no transaction available in our data warehouse. What happened? They can raise a ticket to IT team to check. Then we can check whether the records has been captured properly. We can check the metadata that time and all. Okay. So that's why metadata is keeping there to track everything, what is going on over here. Okay. Till now, any doubt to any of you? I'm telling a lot, but if there is any doubt or anything, you can quickly ask me, please. Okay. Hopefully, no doubt till now. Okay. So just there is operational data warehouse, ODS, and data marts as well. The data warehouse should be there for every project. But this kind of ODS can be there, cannot be there based on project requirement. So what is operational data store? It's called ODS as well. Used to analyze near real-time data. Real-time means actually it's the frequency of data loading is very fast. We cannot load daily to daily basis. Just you can tell it's a very frequent data loading and it's having real time. Okay, what is happening and day to problem solving activity we need to go ahead with ODS. So it's very fast data refresh as well as just like we need to take decision and we need to fix the issue or anything can be done by ODS. What is data mart? Data mart is required mainly for all the project. Maybe I'm storing the information for particular sales. Okay, so maybe I need to store the employee information, the customer information, the customer address or particular outlets information. I mean, which particular customer, which outlets is getting more crowded. Okay, so based on that thing, I need to check in a particular address. We need to grow another new outlets or not. Whether two outlets are very near. So this kind of decision based on each of the fields in the data warehouse, we need to segregate the tables. Okay, suppose the employee table. Suppose there is a fact table which is storing the sales information only. Suppose we have the customer table. Customer employee, those are different as well. This kind of thing. That's like there for marketing purpose, there is one particular table. So for different subject inside the data warehouse, we can segregate between each of the table. Those are called data mart. Okay. So it's miniature of the data warehouse based on each of the subject. We can push the data in a particular table, particular small table that is called data mart. So data warehouse things we are splitted it into data marts. Here's an example over here. A data warehouse contains the data for multiple subject areas in a department in a particular organization. A data mart is a simple form of data warehouse that is focused on single subject area, such as sales, finance, marketing. So for each of the thing, we can store one table. So that is called data mart. Or data warehouse, we can say a collection of tables. Okay. Collection of data mart tables. We can say data warehouse is this. Okay, here is a small example over here. Again, the same pictorial diagram I tried to convey. This is for insurance OLTP. Lots of insurance. A particular insurance company is there. They are not only health insurance or just like this. They're covering property data mart. For property related thing, they're storing into property data mart. Automobile data mart. The insurance papers or every transaction for automobile, they are putting in this one. Commercial data mart. So that is the way we are storing the data in data mart. Okay. So you can understand, but the intermediate process should be also there. The staging layer, everything. They are pushing it to data warehouse. And then the data mart, they're storing into data mart. But over here, I just tried to convey this way. Okay, I remove the intermediate steps to understand you how the data mart can be segregated based on different subject area. Okay, going to the next slide. Okay, from this slide onwards, I'll be quickly telling these things, but tomorrow I'll be covering these things again quickly because fact and dimension it's the most important stuffs uh, what we are storing in the data mart, what kind of tables are there, they can be segregated into facts and dimensions. So this is very much important. What is fact and what is dimensions? In particular data, in particular table, if I try to question how much, how many cell is, how much cell is there, how many quantity a particular customers, uh, how many quantity of the toothpaste, but for the particular toothpaste the customer has bought. So this kind of question, what is the answer? The answer is fact. It's called fact. It's also called measures. Okay. This should be numerical in nature, obviously. So this kind of thing, revenue, what is the cost? What is the number? How many number of accounts are there? Okay. So those kind of thing is called fact measures. And we need to store the same kind of information in fact table. Okay. So in fact table in red color, highlighted red color, you can see those are the measures only. Those are called facts. Sales, quantity sold, price, discount. So all the things are called facts and measures. And those kind of things are being stored in fact table. So now the question may comes, what are the other columns? Okay, this is a particular table, sales table. This is a particular table that is called billing. And those should be the column name. Okay. We cannot store everything in a single table. That's why the data mart will be playing the key role. We need to segregate the thing, sales thing in a particular table, billing thing in a particular table. But those tables should be fact in nature. And over here, those are called keys. Something should be primary key. I already covered what is primary key and foreign key in the earlier chapters. So what is primary key? Primary key should be the unique for that particular table. For sales, we should be having one primary key and the other key should be the foreign key. That's why we can join between this fact table with other dimension table. Okay. And those are, I mean, actually foreign key over here. Maybe in the pictorial diagram, I missed the primary key. So date key should be there. There is another date dimension table. What is dimension? I'll be coming later. So there is another table that is called date, where date key is the primary key. Then we can join with that particular table with the date table based on date key. Okay, so those top three columns in black, those should be the keys of, maybe it should be primary key of that table or foreign key, which should be used for joining with other table. Okay, so this is the concept of creating the fact tables. We need to create all those facts information and which dimensions I'll be joining with this fact table. Those keys should be there. Based on which key the joining should be performed. If you are new to these classes, maybe if you're not aware what is joining and all, I'll be covering covering these things again with the next session, or maybe you can go ahead with the recordings part. The old knowledge transfer recording, you can quickly check over there, so you can understand what is keys. This kind of stuff. What is join? How we can perform the joins and all. Those are very simple. Just you can go through quickly and you can have the understanding. Okay. The same thing is there for billing as well. So those are called fact table. Now, what is dimension? So if I ask the particular table this kind of questions, who, what, when, where. Okay. So what kind of answers we will be receiving? That is called dimension. Okay. So in dimension, this kind of thing we can see customers, geography, time. Okay. And this kind of information, we can see that there is no such numerical information is available. We have store information where you have store key, particular store name, store address, city, state, region, country, this kind of stuff. For a store, different store outlets, we should be having different store key, store name, street address, city, and we can store the same information in store table. Okay, just like the same thing, product table. All kind of product for this organization can store the thing in product table. We should be having product key, product ID, product name, product group, brand, department ID. And over here, this is the primary key for product. I mean, product table, product key is the primary key. Store table, store key is the primary key. That can be joined with the respective fact table to establish the entire data that should be integrated in the data warehouse. So the table is segregated in this way to create the data mart, maybe either in fact table or maybe either in dimension table. So we need to check it properly what should be coming inside the fact table and what column should be coming inside the dimension table. Everything we are receiving from the source system itself, OLTP. But the data engineers have to take decision. They need to check which kind of columns we need to put in which tables to create those data marks. Okay. So that while doing the joins and all, we can fetch every information from the data marts. Okay. So yeah, those are all as for today's session. From tomorrow onwards, we'll be going at the dimension. There are lots of dimension table and the data modeling. This is one of the most important thing. What is data modeling? I mean, the data modeling is nothing but just like we will be joining between fact tables and dimension tables. There are several strategies to join the thing. So I can show the thing to you, and some more examples I'll be covering in tomorrow's session. So that's all for today. If there is any questions, you can quickly ask me. Okay, no questions. Fine. Then thanks everyone. Let's connect tomorrow for the more insights on fact and dimensions and dimension modeling and the other stuffs to cover the business intelligence. Okay. Okay then. Thanks. Thanks everyone. Bye bye. Have a great day.
Thank you, Sopik. Thank you very much.